Hey guys, so my name is Ilya Grigorik. I work on the Make the Web Fast team at Google. I also work with the Google Chrome team. So my focus is primarily on how do we make the web faster as a whole and also make Google products faster and your sites faster as well, right? It's like what can we do in Chrome, for example, to make your pages load faster? So it encompasses all of those things. And actually, Rick mentioned this presentation that I shared internally. I think he's referring to a presentation I did on radio performance, mobile radio performance specifically. And this presentation is kind of an evolution of that. I actually think of this one as more practical and hands-on for things, what we can do to make our mobile pages faster. And the way I think of this is, so this is the, how to break the 1,000 millisecond barrier. I'll explain why the 1,000 millisecond barrier. And also this concept of the critical rendering path, which is something that we internally at Google, certainly looking at all of the different Google products, Gmail, search, and all the rest, that's what we're focusing on. And I want to tell you about kind of the simple things that we're realizing that we should be doing. So I think of this process as this is the breakthrough science of going to the basics. Like after we've done all of the crazy optimizations and we're all interested in like how do we make CSS3 selectors faster for the specific edge case in a web view that's running on this device. And that's cool, but at the end of the day, I think what we're realizing is that really we need to get the basics right. We need to understand how the protocols work, how the mobile radio works, what kind of constraints those things impose, and then if we get those things right, we can focus on the rest. So basically the way I think about web performance is this diagram. If you know this diagram, I think you can figure out, like this diagram will show you every single bottleneck, a possible bottleneck in your application. So this is the process that I usually go through when I'm analyzing an application. And the one that perhaps most relevant to a mobile network and our kind of conversation today is going to be this first one, which is the network, right? So there are certain characteristics of a mobile network that are just different from when you have a tethered connection, when you plug into the wall, if you will. And then there's this entire process for how do we get from bits on the wire, or in the air, I guess, to HTML and CSS. How do we put all of that together on the page? How do we render that page? And then how do we paint the pixels on the screen, right? So this is the critical rendering path in itself. Each one of these elements, it could be a bottleneck in your application. Different applications will have different problems. And then once you've loaded this, it's actually the same diagram. You're just kind of stuck in a loop between DOM, JavaScript, and CSS, and you're just painting at 60 frames per second, right? So that's, in a nutshell, that's web performance. So our focus is on this critical rendering path, which is to say, what do we have to do, or what can we do, rather, in how we structure our apps to make it such that we paint the useful pixels on the screen very fast, right? There's a difference between, so let's take an example. We have two pages, right, A and B. Both pages take 10 seconds to load, right? So that's when the spinner stops spinning in your browser. Now, one page actually gets some useful pixels on the screen, let's say text, after 1 second. The second page waits for 9 seconds and then paints the text. Right? There's a world of a difference. If you look at the page load time metric in itself, it doesn't distinguish between this difference. But there's a world of a difference between these two use cases, right? So for example, you look at Amazon.com, you'll find out that the page actually takes a very long time to load. Like on a complicated product page, it can be 20 or 30 seconds because they're loading all these widgets in the background, they're progressively filling in the content, but you can start interacting with the page very, very quickly, right? And that's what we mean by critical rendering path. Page load time is perhaps not the best metric. So before we talk about the logistics of how we go about doing this stuff, why do we care about 1,000 milliseconds? Well, it turns out that there's been a number of user studies that have been repeated over the last 20 years. This first user studies were applied in context of just developing desktop software. They've been repeated on websites. They've been repeated in mobile contexts as well. So basically what we're realizing is that there are certain constants in our human perception. Right? If we respond to user input within a couple hundred milliseconds, it feels instant. Right? You click on a button, you get feedback, that's what you want. After about 1 second, this is kind of like a threshold barrier where you may lose context of what you're doing. So you click a button, it's kind of sitting there, it's not really doing anything, and after 1 second you go, oh yeah, I got to email Bob, and I got to talk to Sherry, and before you know it, you may have lost the user, right? After about 5 seconds is the barrier where people really start wondering, like, is this thing working? Did I click that button? If you don't provide any sort of feedback at that point, many users are either clicking the button again, right, which usually makes the problem even worse. And after about 10 seconds, if you don't give them any feedback, they'll usually just abandon the task. So these are kind of the context, or the constants rather. So the reason we're looking for that 1,000 millisecond barrier is we want to keep the user engaged, right? So for example, take the context of Google search. We want to make sure that we serve you the page, and you're typing the query, you hit enter, and we don't want you to switch. Like you're thinking about the context, you're trying to refine your query. We want you to help you iterate on that very quickly without any sort of context switches. And that's ideally what you have on your site as well, right? The user sees the product, they click on the description, they read the description. There shouldn't be much wait between that. So that's why 1,000 milliseconds, right? And now, given this kind of barrier, 1,000 milliseconds, let's work backwards as to where does the time actually go? 1,000 milliseconds is actually not a lot of time. And what do we need to do to actually meet this goal? But before we do that, right, like one of the questions would be, okay, great, these are the constants, but why do we care about this? And especially in context of mobile. So not surprisingly, right, a lot of users expect that mobile should be no slower than desktop. Right? Why should it be? After all, if I'm on the go, usually that means I only have a couple of seconds, I'm standing in line, I want the answer quick. If anything, the web should function even faster, right, when you're on mobile, because you have that context. So most users expect, they're not willing to accept a slower experience just because it's mobile. So as engineers, we may be, we put up our hand and say, hey, the networks are slower, the latencies are higher, I'm sorry, I can't do anything about it. And the user says, too bad, right? Like, I have things to do. So the bad news is, a lot of users, when we survey them, tell us that they've actually had problems when they try to access a lot of sites on the web, right? So more than half. And then when you actually ask them what was the problem, usually they'll say, well, it just took a very long time. So either I had to wait a long time or it didn't load at all, which is the worst case scenario. So there's a couple of cases there, right? Like maybe you're out of service, you don't have any connectivity, not much we can do there, right? That's more of a carrier question. But assuming you have some connectivity, what can we do to make your sites faster? And then perhaps this is the most kind of the money quote right there, which is if people experience this bad loading behavior, they would abandon the site, right? So half of them would just say like, look, I searched for an awesome widget. I clicked on the first search result because I wanted to get your awesome widget. It didn't load, so I went back. I clicked on the Amazon link. That worked just fine. And now I'm not coming back to your store. So unfortunately, we train users to expect this slow experience, and they kind of remember that, and they don't come back. So that's all of that's to say speed is the future. For some applications, speed is the future. Certainly for something like Google Search, speed is one of our core features in that product. For your specific application, it depends completely, right? First of all, you got to make sure you're selling the right widget, and then you should be optimizing the speed of it. But I think that's relevant in a startup context to keep in mind. So with all that said, we know that we have some constraints with respect to the network. Mobile radio works very differently than a wired connection when you hook up to the wall. And at the same time, though, you can say, well, hold on a second, right? We know that there's some problems there, but everywhere I go, there's flyers and posters and everything everywhere. Like 4G will make things fast. AT&T is telling me they got the fastest network in the world, and whatever gigabit speeds. Like this thing is going to be a solved problem. Just like 10 years ago, we could just wait for our CPU clocks to double every year. 4G will solve all things, right? Not quite. So I have an entire 1-hour presentation on trying to explain this diagram right here. So if you guys are interested, this video is actually available on YouTube. But let me just walk you through this one example of this is how the radio works. So this is how we deliver a single packet of data from your phone to a destination server, right? So just stay with me. Let's say I have a phone in my pocket. So right now it's idle, right? And because the radio is actually very energy, it consumes a lot of energy, we like to turn it off as much as possible. We like to keep it off as much as possible, right? So the radio in your phone is the second most expensive component in terms of energy use after the screen. So because of that, we have to turn it off. So now that my phone is idle, the radio is off. So now I turn on my phone, I type in your website name, I hit go. What happens? Well, before we can actually send any sort of data, my phone will have to take some time to talk to the local radio tower to get a permission to send data. So think of it as a moderator in a room, right? Before you can speak, you need to talk to the moderator and get their permission to speak. So that's what's happening here. First, we talk to the tower. The tower says, okay, hold on, I got 150 people trying to communicate at the same time. I have this little slot right here. So please talk at this specific time with this specific efficiency and use this codec. So you get that assignment back, and this step right here actually can take quite a bit of time. So in the latest 4G networks, this can be up to 100 milliseconds, which is actually pretty good. In 3G networks, which is likely what most users are experiencing outside of this area where 4G is prevalent, this one step can take up to 2.5 seconds. So before any data can be sent, there is up to 2.5 seconds of just negotiation with the local, with your carrier to say like, hey, I'd like to send some data. Once you have this assignment, you can actually send the data to the tower. The tower sends it to this serving gateway, which multiplexes all the data in a core network of AT&T or somebody else. It sends it to another service within the network called packet gateway, and the packet gateway basically routes it onto the public internet. And only after that fourth step does the packet traverse out of the carrier network and onto the public network, where it then starts to find its path towards your service or your servers. So here are some numbers that I pulled out from the AT&T technical FAQs. By the way, when you see any sort of advertisements on fastest, latest network, whatnot, usually what they mean is bandwidth. Right? It's like we can give you 10, 20, 30 megabits of bandwidth. Nobody ever talks about latency, mostly because the latency numbers are pretty terrible. But latency, as you will see, is a critical component. And if you dig deep enough, you will find these numbers. So for example, most users for AT&T are going to be in this bucket right here, HSPA+. Right? That's what's being marketed most of the time as 4G today. So what this tells you is that a packet traversing from your phone and just to that 4 step will take somewhere between 50 to 200 milliseconds. Right? Then it has to get to your server. Then your server needs to actually service that request and send the data back. So, okay. If that went all over your head, don't worry about it. We're going to look at an actual example. So first of all, what does it actually take to render a page on the web today? Right? Like you open up your browser, you type in google.com, hit go. What happens? Well, it certainly takes more than one packet too, right? So first of all, we need to figure out what is google.com or what is awesomewidget.com, right? Like what IP address stands behind that. So that's a DNS lookup right there. We need to resolve it to an IP address. That's one round trip to the DNS server. After that, we actually need to perform a TCP handshake to establish the connection. That's another round trip to the server. Once we do that and we have the connection established, I'm actually skipping if you're using HTTPS or TLS security, then there's another 2 round trips to negotiate all the crypto stuff. Let's put that aside for a second and say, well, okay, now I'm going to send the HTTP request, and then after that, you're going to send me some data. So what this should tell you is that there's a lot of round trips involved in just servicing one single HTML page, right? And the caveat here is, of course, how many of your pages are single HTTP pages, right? Just some markup, some text. We also have images. We also have CSS and JavaScript and all the other stuff. In fact, if you look at the latest stats from HTTP Archive, you'll find that an average page on the web today is composed of over 90 assets, right? So that's images, JavaScript, CSS, and all the rest. So we need to make 90 of these requests, and we need to repeat this process very, very quickly. And by the way, all of this needs to happen within 1 second or 1,000 milliseconds, right? So that's kind of a hard problem. And let's do the math, right? Like, let's work backwards. Let's say we have our 1,000 millisecond budget. Where does the time go, right? Just assuming this one HTTP request. So the first step that I described where you're talking to the moderator on the mobile network, that's the control plane latency. So this only happens the first time you wake up. You need to get permission to speak, but once I give you that permission, you can basically start talking. So that's a one-time cost. On a 3G network, that can be up to 2.5 seconds. Then we need to do a DNS lookup, so I'm assuming these 200 and 100 millisecond round trip times, which I think are actually fairly aggressive in most cases. So these are, I'm going to say, optimistic numbers. So DNS lookup, we need to do the TCP connection. Then if you're doing TLS, then there's another couple of round trips, and then HTTP request. And what you end up with is we spent anywhere from 600 milliseconds. So in the 4G case, let's say roughly half a second went just to the network latency, right? We have not transferred any data. This is just us and the speed of light, and that's how long it takes to do these round trips to communicate the fact that we want to retrieve something from the server. And this is just one request, right? So we've already blown half of our budget, half of our 1 second budget on this latency, and the only thing we've done is we've asked for the index page. So this is starting to look pretty bleak at this point. Then there's another complication. You guys may know this already, but TCP has this nice little property or algorithm at the beginning, which is known as TCP slow start. And despite its name, it is a feature, not a bug. And the way it works is, or the reason we actually have it is, let's say we want to communicate between my phone and your server. We don't know what the capacity of all the different links in between are. So for example, an intermediate router could be overloaded because there's some, I don't know, giant event happening, there's a lot of live streams happening, and there's just not a lot of capacity. If we were to start transmitting at full speed, we could send a lot of data that would never get delivered. It would just build up in the buffers, it would get dropped, and basically we would overwhelm the network. So if all of us just started transmitting data at full data rate, we would get into the state known as the congestion collapse. And this is in fact what has happened, or what happened in the mid-'80s. So originally TCP didn't have this mechanism. We went without it. Then the network got into the state of congestion collapse where at the time, if you read the discussions, they were saying that certain packets would take like 12 hours to get to the other side, right? And we're talking about a small network. Just because these packets were sitting in these buffers, they were getting retransmitted, and it was just a total disaster. So a TCP slow start is a way to mitigate that. And how does it work? Well, just like its name implies, it says, I'm going to start slow. I'm going to send you one data packet. I'm going to send you 4 kilobytes of data. Right? And if that gets through, that means there's sufficient capacity in the network to transfer 4 kilobytes. If you acknowledge that, I will send you 8 kilobytes of data. Right? You see where this is going. If you acknowledge that, that means we have enough capacity. I'll double that again to 16. So that's why you have this exponential growth. Right? So we start small, and the value here has actually changed over time. Originally, it was 1 packet. Then we changed it to 3. And just recently, last year, or this year, in March, it was changed to 10 packets. So you can send up to 14 kilobytes of data. So this is pretty low-level stuff, but this is very important. So despite the fact that your phone, your 4G phone, or your desktop connection at home, or cable connection, I should say, can be 20 megabits per second or a gigabit per second, you're not using full capacity of that link. You'll be sending 14 kilobytes of data, and that's it. So let's do a hands-on example. Like, how does this actually work? We're going to try and fetch a 40 kilobyte HTML file, right? And 40 kilobytes turns out to be kind of the average size for a page today on the web. So this is what's actually likely going to happen. Let's assume that you have a 5 megabit connection. This is kind of a good 4G connection. As we'll see, this actually has no impact whatsoever on web performance. But let's assume that we have a 200 millisecond round trip time. Right? So if you think back to the numbers I shared with the AT&T network, this is actually also very optimistic because it means that your server is probably very close somewhere to the AT&T exit point on the public network. So these are pretty optimistic numbers. Okay, so let's start. I'm assuming that DNS and all the other things have already happened. I just want to get the actual HTML file. So what we're going to do is first establish the TCP connection. That takes that first round trip since SYNAC, right? So no data has been exchanged yet. At this point, I can actually make the HTTP request. So I send it, that's 100 milliseconds. Then your server takes some time to make that to generate that response. In this case, it's going to take, how much did we say, 100 milliseconds as well. And then it's going to send me some data, except it can't send all 40 kilobytes because TCP slow start, right? So it'll send me 14 kilobytes in this case. And I will acknowledge that I received that data. Those acknowledgements go back to the server. The server then sends me the remainder, right? So if you add up all the latencies, we've just spent 700 milliseconds doing all of this. So if you ever wondered why it takes 3 to 5 seconds for a page to load on your mobile phone, which has 90 resources, you can see where this is going, right? Like this is just speed of light working against us. Like if we could reduce all these latencies to 1 millisecond, everything would be very, very fast. The problem is we haven't yet, unfortunately, figured out how to go faster than the speed of light. So that's on the agenda, I guess. So kind of the first interesting takeaway, if we're looking to build these experiences where you have responsive sites that can keep the user engaged and you want to respond to them within 1,000 milliseconds, you have to throw away basically at least half of that budget. This is optimistically on the latest, even the latest 4G network, just to network latency. So you don't have much room to work with here. And in the best case scenario, if you actually work through the previous example, you'll discover that we have to render something useful on the screen within one round trip render, right? So we can ship you, let's say, 40 kilobytes of data, and just in that 40 kilobytes, there should be enough information to the browser to let it render something useful. Maybe that's the preview of your product description page. Maybe that's something else, the beginnings of your news story, etc. So maybe a third thing I should add here is, if you're building apps, especially for mobile, you should never couple user response with network activity, right? You should acknowledge the fact that you've sent something to the network and respond to the user. Maybe that's a spinner and a button, or acknowledging the fact like, yes, I've sent this, I'm processing this in the background, and all the rest. So this is the concept of perceived speed. Okay, so that's kind of a very low level of how the network works, and that's just a basic preamble for, like, these are the constraints that we have to work with. Now let's look at a very simple example of actually constructing a page, right? Like, how do we make a page that loads within 1,000 milliseconds? So this is a valid HTML5 page, believe it or not, and it is just very simple. It has a title, it has hello world, and the only thing I'm adding here is a style sheet, right? So a style.css, and that style.css is a very simple file that contains two rules. It bolds the hello world, and it hides, it bolds the hello, and it hides the world, right? So if you render this on a page, you should just get a hello. Like this is as simple as it gets. This should take like nanoseconds to render. All right, let's see how this works. So we request this page, right? And let's say, just for sake of an example, like this is clearly less than 14 kilobytes, but most pages are much larger. So let's assume that we only ship the beginnings of this, right? This is where the cutoff happens. You can imagine how this would happen in a larger page. We've only shipped this much. The browser has received some of the HTML. It is actually able to start constructing the page. Like, it can parse those little bytes and figure out, like, do I need to fetch anything? At this point, the answer is no, right? And there's nothing painted on the screen. Then we ship the second half of this, and we discover that, hey, there's this external style sheet that we're asking for, style.css. So I'm going to send the request for that, right? I can't really render anything on the screen until I have styles. And this is a very important point. We can't render anything on the screen until we have the style sheet, because I think we've all had this experience, usually due to a problem, a networking problem, where the page loads, but the CSS is missing, and you just get this like garbled text all over the page, right? White background and not useful layout. That's what happens, right? We can't and we don't render anything until we have the styles, because otherwise the problem is known as a flash of unstyled content. So even though we have all the HTML, can't do anything. Let's say we ship some of the CSS and then we're blocked again. Still, we can't render anything, right? So we were blocked until we get all of the CSS. Then we get we construct what's known as the CSS object model, and at this point, it's still blank. This is terrible. And what happens now in the browser, this is kind of an internal view, is we've had the HTML, right? We built this tree of nodes. We also have the CSS, and now we try to marry these two things and say, like, okay, we have this p tag, and I know I have a style associated with it, so I'm going to need to apply that to create a render object. Similarly, I have a rule for a span tag, and I'm going to apply it to the world. And if you recall, my span tag was actually display none, right? So on the other side, we create this render tree that says, well, if you're going to display none, this element, I don't need to render it clearly. So what I need to actually render is that hello thing. Okay. Finally, after all of that work, we can perform layout, and we can actually paint the page. So at this point, we have something visible on the screen, right? But you notice that we had the HTML document, and we were blocked on CSS for a while. So one thing also to take into account is all of this processing is not instant, right? It takes time for the browser to actually lay out the pixels on the screen, to paint them, to transfer the textures to the GPU and get it visible. So I always allot at least 100 milliseconds for just internal processing. Maybe that's more of an aside. So the first interesting takeaway is you want to deliver the HTML as quickly as possible to the client. So one little trick, fun trick that we do on Google Search is you send us a query, we get that first TCP packet, we don't even look at what the query is. Like, we don't even care. We just say, look, you're asking for the search page, I'm just going to flush the header. Like the header is always the same in all the pages, right? The name, your username, and other things are dynamic, but those things are filled in by JavaScript. So we can flush the first X bytes of that search page immediately without even processing, like, what are you asking for? And this is a nice property of Google search pages because we know exactly what you're looking for. And because of that, we can actually get the fastest response time to the client in terms of rendering. We can start rendering, even the header is useful, right? Because it gives feedback to the user that, yes, we acknowledge your request, we're processing, we're working on it. And only after we do that do we dispatch the query to our search index, aggregate the results, and then return you the results. So that's tip number one. You want to, instead of buffering the entire HTML response, you want to flush it as quickly as possible, even in small chunks, right? Like I've got my header, flush it. I've got my body, flush it. That also allows us to discover other resources like CSS very early. So if you've ever seen the rule, the performance rule for put your CSS at the top, this is exactly why. Because we need CSS to paint things, and we want to discover it as quickly as possible. So because of that, you want to put your CSS at the top. Let the browser discover it as early as possible. Except I've conveniently omitted something very, very important, which is, unfortunately, our friend and foe, JavaScript, right? Increasingly, more and more of the web today is being built using JavaScript to the extent that we're bootstrapping our entire applications via JavaScript. So why is this a problem for performance? Well, it can cause some quite interesting behavior. So if you put JavaScript into this equation, right, we're kind of slowly building up that diagram that I showed at the very beginning. The interesting property of JavaScript is that JavaScript can query CSS. So in your JavaScript, you can write code that says, grab this element and tell me what the style of this element is, right? And we can't tell you what the style is until we have the CSS. Vice versa, you can actually query the DOM or write into the DOM with JavaScript. So basically, what this tells you is that, oops, let me go back for a sec, is that JavaScript can block both CSS, can block both on CSS and in the DOM construction, and it can block those things as well. So this is why you will always see, every web performance presentation you will see will talk about use async scripts, right? And there's a couple of different ways to achieve this. The first is you can actually just add an async element on your script tag. And basically what this does is kind of a handshake with the browser to say, hey, I'm not going to modify what comes in a document tree after me. So maybe that's a little abstract. Let me go back. I actually have an example here. So I'm executing the script, right? And one of the properties of JavaScript is you can issue this. You can say document.write. And what that does is it modifies exactly what goes on into the tree after, right? So for all I know, you could wipe everything below. Like let's imagine there's a bunch of HTML below here. This script could wipe everything below and completely rewrite it, right? So I have no idea. So I need to stop the world and I say, okay, I'm going to execute all of this JavaScript, and then only then can I proceed. Because if you rewrite everything after, what's the point, right? So adding this async tag is basically a handshake that says, look, I'm not going to do that. And because you give us that permission, what we can do is we can stop, we can avoid blocking on the network. So if you look at the top chart here, right, we're parsing the HTML, we encounter the script tag, and then you say, file-ags. We stop the world. We need to wait until that file arrives from the network. We can't paint anything on the screen. We need to execute it, and only then can we proceed. Using async allows us to decouple that, which is very, very important. Similarly, you will find these things. This looks kind of scary, but this is an example from Google Analytics. This is the asynchronous analytics trackers, where basically this achieves the same thing as the async tag that I showed you in the previous slide, but this is the bulletproof way to do it with old browsers, the IE6s of the world. It will achieve the same thing. If you're not targeting IE6, if you're lucky enough not to do that, then you can avoid this and just put an async tag. But if you have something like this on your page, that is a performance problem, right? It's an easy thing to fix, and hopefully this will motivate why you should do that. So this is the exact snippet from, I guess, this is +1. But same thing can be applied. Just insert any other URL in there. It works for all other scripts. OK, so this actually takes us basically all the way to the end, which is you want to stream the HTML to the client. You want to make sure that you deliver the CSS as quickly as possible. and you want to eliminate JavaScript because all those things are interdependent, right? We can't render until we have the HTML, obviously. We don't know what we're rendering. We need the styles, and JavaScript can block both of those things. So you kind of have this funny dependency graph. And depending on how you structure this page, you can create patterns which are either efficient or very inefficient. Oftentimes, this is an easy thing to fix as well. So let's take a look at an actual example. So what I'm going to tell you is that for rendering something under 1 second, I'm not talking about rendering the entire page, right? The entire page could be very long. So coming back to that Amazon example, if you've actually ever scrolled through an entire page, right? If you take a screenshot of the entire Amazon page, it's going to be very, very long. We don't need to render all the content in under 1 second. We just need to render something useful on the screen, like a preview or some user acknowledgement, right? I want to start reading the story, and then you can stream in the images in the background and all the other stuff, and the social widgets. Like that stuff shouldn't block rendering of useful content on the page. So to get there, basically we have to work with these constraints. And these are the constraints that we're looking at. You know, how do we make, for example, search or Gmail or other products like Google meet these criteria? You need to have a fast server response time. That's a given. One thing that I didn't talk about explicitly, but this should be just obvious based on what we discussed, is redirects on mobile are extremely, extremely expensive. And usually that's because we have a different DNS name, which requires a new TCP connection and DNS lookup, and yet another TCP slow start. So very important to avoid them as much as possible. So here's an example, right? Like this is the typical or prototypical HTML page. This is how we all start, right? We have all.css and application.js, and then we have our markup here. So this page will not meet the 1 second criteria. And now you know why. Because we may be able to fetch all this HTML in one chunk, right? But then we need to make a network request for the CSS and the JavaScript, and that will take up to another couple hundred milliseconds. Or if it's in a different domain because you've done all of your optimizations and you're using a CDN and you're doing domain sharding, that actually works against you here because now you have more TCP time and DNS lookups. So an interesting optimization that you could do is you could say, okay, well, maybe I don't need all of my CSS to render the above the fold, right? Like maybe I just need the CSS that is relevant for the header. And in fact, if you look at the Google search page, you'll find that we inline all of the CSS exactly for this reason, because we want to allow the browser to paint something very quickly and then proceed with the other content. And you know what? Do I need all of the application.js stuff? Like I have this user validation logic, form validation logic, and all the rest. Do I need that for my bootstrapping page to make it visible? Probably not, right? And in fact, this applies to a huge fraction of pages on the web. Things like even loading jQuery. Oftentimes, most of the time, jQuery is used to enhance the page in the sense that you can paint all the stuff on the page, and then we attach click handlers and other things to all the elements on the page which react to user doing something with those elements, right? So you can paint those things before you attach all of the jQuery handlers. So most of the time, I can actually just take that JS file, completely defer it until the end, and get much better performance simply by doing kind of the small optimization. So here's an example, right? Like here's how we would approach it, for example, for search. We would say, okay, well, I only need the .main and the .left nav, or like a couple of these, a subset of my CSS rules. And what I'm going to do is I'm going to inline it into the page. Yes, that will make the page bigger, but that allows the browser to paint with one RTT, or just one round trip of delivery. Similarly, I will extract just the scripts that I need to bootstrap the page. Ideally, I shouldn't need any at all. Of course, it depends on your app. You know, if you're building everything in a framework like Ember or Angular or something else, then we should have a separate conversation about that. Then we can paint this, and then after we've done our first paint, we can actually load the rest, right? Like I'll load my carousel plugin and my other plugin and my form validation plugin after I've painted the page. So if you next time you load, for example, Amazon.com, look for this because you'll see it, right? Like even as you scroll, they're loading elements on demand. And this is why, because they want to get pages as quickly as visible as quickly as possible. So above the fold CSS, paint the actual page, then load the rest, right? Oftentimes these are fairly simple modifications that you can do, and they'll make a world of a difference to your page. So these are kind of the basic takeaways here. inline the above default CSS in JavaScript if you can. Ideally, all of this would fit into up to like 14 kilobytes of data. Now that could be a fairly hard thing to meet, but in practice it turns out to be fairly plausible for most applications. And then defer everything that's non-critical. And if you're really down into the kind of the performance weeds of optimizing your application, what I do today when I work with the Google team working on any given product is we actually start counting the RTTs. Like we open up the markup of the page and we say, this is going to be one RTT. Now we're making another request here. And I can just, without even looking at how the thing is rendered, I can look at the structure of the page and say like, well, you're at least 15 RTTs plus to render this thing, which means on mobile and a 3G network, you're sitting at 8 seconds plus. What can we do? Now the question is, what can you do to optimize that? So let me show you a little demo. We've actually built a tool and released a tool just recently, PageSpeed Insights, which evaluates all these criteria and actually helps you with hands-on advice for doing this kind of thing. So for example, what do we want to load? Let's do BBC. So this is a public tool. If you just use your favorite search engine to search for PageSpeed Insights, you'll discover a link for this. And with luck, it should load right here. OK, so you can see that we're actually giving you two different scores, one for mobile and one for desktop, right? So we've recently flipped the tool to focus on mobile first. And this is just a reflection of what we see at Google, where a lot of traffic is migrating to mobile. It makes sense to focus on performance and designing for mobile first. So OK, let's look at some of these. So first of all, it tells me that, hey, there is a whole bunch of render blocking JavaScript and CSS files. Now you know what that means. This is exactly what we discussed on this page. If I expand this, it'll tell you that, hey, there's 7 different resources that need to be fetched before the browser can paint anything. So this immediately tells you that this does not meet 1 second criteria. This is likely in the 5 second plus territory, if anything. And if we look through some of these, right, there's double click. Do you need the ads to load before you can paint the page? Can you fill in the ads after the page is painted? I think in many cases that's a legitimate thing to do. There is some partner scripts, another ad, yep, and a couple of CSS files. So I think a lot of the stuff can be safely deferred until after the first page or the above default content is painted, and then you can proceed. And that will help significantly in improving this. Another one here is, well, we have 3 redirects, right? So I typed in BBC Co UK. They sent me to www, at which point they sent me to an m dot. This is very costly because this is a new DNS lookup. This is a new TCP connection. This is a new HTTP request, which then tells me, oh, no, it's not here. Go check there, right? And go over here. So at the very least, they should eliminate the www. They should be smart enough. Like, it's not very hard to configure your server to say, if this is to apply this logic, whatever this thing is checking on this stage, right? And that will shave off hundreds of milliseconds on 4G, even seconds on 3G networks. But generally speaking, you want to avoid redirects in general. They're also not caching images and a bunch of other stuff, right? So let's look at something else, Guardian. I don't know why I'm picking on UK sites today. Right, so how do we determine what the above default is? And that's a great question. I think this is where you need to apply your own product knowledge, right? We have some heuristics. I'll show you a demo of, we built a couple of open source tools that can automate a lot of stuff for you. And there we have to come up with a way that works most of the time. So we actually have 2 approaches. One is we just pick a very big cutoff, and we say, like, most pages are very long, but we're going to assume a worst case scenario, like you're sitting on a 30-inch screen, which is rotated this way. So that's going to be our cutoff. That's above the fold. We can do better, right? We actually have a different approach where, and this sounds kind of crazy, but it works. First, we add some JavaScript to your page, which gathers data from the clients that visit your page. Right? Whenever they visit, we walk the DOM, like what's visible, and we beacon that back to the server. a bunch of different people come to different screen resolutions and all the rest of your site. We aggregate that data, and after some time, we can make a pretty good prediction for like, this is a meaningful above the fold metric. And then we start inlining that content. All right, so Guardian is actually doing a lot better, and I know why, because we've been working with them. So they actually don't have any critical CSS or JavaScript. So if you try to load Guardian Co UK, and I think that actually they're doing an A/B experiment, so you may or may not have the nice experience. In this case, we got the nice experience. But this page loads much quicker because they've inlined all the critical styles, right? So the only thing that's happening here is there are still redirects, so we're still trying to convince them to do a better job of that. But otherwise, this is a page that will actually render pretty quickly, even on 2G networks. So this stuff makes a world of a difference. Okay, let's go back. So definitely run this on your own pages. And by the way, I didn't cover this, and I guess I'll come back to it in just a slide or so. But there's a bunch of other rules that we cover here for things like, are you compressing your content? Are you gzipping your content, right? At the beginning of the presentation, I had this point of a lot of this work is going back to the basics. Well, I actually ran some analysis. So I looked at the list of attendees for this presentation. I grabbed the site names and I ran a bunch of stats for like, what are you guys doing, and what can we do better? And I'm disappointed. So about half of the sites I checked, right, didn't have cache headers. So what we're doing is on average, we're downloading like 1 megabyte of data per site, and this includes JavaScript, CSS, and images. And we're not specifying cache headers, which means that anytime the user visits your page, they need to re-download the entire megabyte, right? That is bad. I should be able to fetch that CSS file once, and then my next navigation should be near instant. So that's problem number one, and that is easily fixed. No matter which server you're using, Apache, Nginx, or even IIS, that is usually either a config flag, or it's a checkbox in IIS, or it's just a one line in your Apache or Nginx. So if you don't know how to configure that, talk to me, email me, I'll be happy to help you out to sort that out. The other one that I find shocking is missing gzip, right? So it turns out a lot of assets are not being compressed. Like we're transferring, remember the 40 kilobyte example that I showed you? With gzip, we can compress that file by 80%, usually, if it's a text format. So CSS, JavaScript, and all that, like JavaScript is actually the second biggest component, or third, I should say. No, sorry, second. The largest component of any web page today is images. Second one is JavaScript. We're transferring on the order of hundreds of kilobytes of JavaScript. By compressing it, we can make it much smaller. So that is, once again, a config flag on your server. So if you have questions, talk to me, and I'll be happy to do that. One, I guess, gotcha that I've discovered with gzip, and I think I've noted it here, is I think one of the reasons why a lot of sites are missing cache headers and gzip is a lot of sites are using Amazon Web Services, and there's a couple of gotchas. First of all, S3 is not a CDN, right? It's a blob store. You can certainly use it as CDN, but it's not meant to be a CDN. And the problem here is you can shove files into S3, but if you want to serve them compressed, you also need to upload a different copy, which is the compressed version, right? So you need to upload 2 copies into S3. So that's something you just need to be aware of. I think this is just general lack of awareness. And ideally, you should actually just use CloudFront. So you can still use S3, and you can use their CDN, and you can back it by S3. But then you need to upload these 2 types. So that's one thing. I think that's an easy thing to fix. The second thing is adding caching headers. So this is coming from your server. This is usually the same thing. You just say, if it's a static asset, give it a day lifetime or something like that. Simple thing to fix. And then a lot of sites were using multiple redirects. I think the largest one I saw was a chain of 4 redirects, which is definitely 4 too many. Ideally, you should have 0, and the question is, how do you get to 0? Because now I do have a mobile site and I have my desktop site. The answer is you use the responsive design approach of, there's a trade-off there, because if you design a custom-tailored mobile site, you could say, well, then I can optimize everything. Like my markup is tailored to mobile and smaller and all the rest. But you incur that cost of redirects, and that oftentimes is much worse. So once again, this whole separate topic. But responsive design is the answer there. right? And you want to avoid these intermediate redirects. Okay, some tips. So based on the analysis that I've done a lot of the sites, there's actually quite a few sites that put analytics beacons directly into the head of the page. So they make them critical, right? So this is Google Analytics. This is other analytics scripts like Mixpanel, other A/B testing things, where you have it in the page. And Google Analytics does not need to be critical, right? Like it doesn't. You don't need to beacon a page view before you can render something useful to the screen. You should be using the async versions. Same thing applies to social widgets. I found a whole bunch of sites which are injecting, the plus buttons, the Twitter widgets, and the Facebook widgets, which are blocking rendering. That shouldn't happen, right? Like I should be reading your article without having the Facebook widget blocking the entire article, or the Google Plus widget, right? We're all guilty in this. Many jQuery plugins. Actually, hold on, before I mention that. So widgets and maps, like Google Maps, I found also a bunch of scripts, right? Like on the bottom of your page, you have a map that's being displayed. That doesn't need to be critical. So same thing. Many jQuery plugins, I found sites with dozens of plugins that are being loaded. Nothing wrong with that, but once again, they don't need to be critical, right? These are all things that are blocking your rendering. And for at least half the sites that I looked at, I could defer all of the JavaScript and make them render a lot faster by just punting all of the loading until after the first paint. CSS starts to get a little bit more interesting. So how do you identify CSS for above the fold, right? One little tip that I have for you guys is if you open up your Chrome DevTools and you go into audits, you can run a performance audit, and in there it'll tell you, hey, you've loaded all these files, so style.css, fuff CSS, I'm not sure which page this is, and out of all of the rules that you have on this page, on this document, 60% of them are not being used. Right? So it's a common best practice today to say you want to concatenate all your files because that reduces the number of requests. So what I'm going to do is I have my modular CSS, and I'm going to concatenate it all into ginormous bundle.css. I'm going to serve that to the client. That hurts performance in terms of rendering. So actually, now that we've told everybody and convinced everybody to do this performance optimization of bundling files, we're telling them to undo that, right? To break it apart and go back to modular because there's a trade-off there. So here's an example, right? We've actually built a couple of open source tools. So this is being developed at Google. We have a plugin called PageSpeed, and we have plugins for the Apache server and Nginx server. So basically what it does is instead of just being a static file server or even serving like PHP or Ruby or anything else, we inject an extra step in the server where we intercept the HTML that's coming out. We rewrite it, we concatenate files, we optimize images, we do all this stuff on the fly and then serve it to the client. So for example, for prioritizing critical CSS, inlining that top stuff, we actually just have it automated down to a filter. So you go into your config file and you say prioritize critical CSS, and it'll do all that work on the fly. Now, you can do this work on your own, right? You don't need this necessarily, but oftentimes we find that this is, for people that are not tech savvy, like I just deployed a site and I'm a webmaster and I just run a small business, like critical CSS, what's CSS to begin with, right? This is our answer to those people to say like just put this in or let your hosting provider put this in and don't worry about it. So here's a very this is a hands-on example. This is the same page. If you go to mod.pagespeed.com, we actually have hands-on examples of like here's a page before, here's a page after. So this is the exact same page, and I'm assuming that most people here will be familiar with the waterfall diagram, right? This is at the top you have the HTML request and then a bunch of other files. So here's the original page, right? So what it tells you is we have the HTML file, and then we have a whole bunch of CSS files, blue, big, using import, and a bunch of others, right? So just CSS. So the way this works is we download all of the HTML. We can't paint anything, right? So we need to download all of these CSS files because they could overwrite their own styles. Once we have the last CSS file, at 4 seconds in, we can render something useful on the screen. So that's what you're seeing here. Now, what we've done here is we've applied the critical CSS. We said, well, let's extract out of all these files the stuff that's actually needed to perform the paint. Let's put it inside of a page. And what happens is we download the page, we paint at 1.3 seconds, and then we load the rest after, right? So this is like a 3x improvement in rendering speed. To the user, the page hasn't actually changed, except that it's just being painted more quickly. And here's a diagram that basically shows you the visual progress. This is something that we are starting more and more so to focus on the Chrome team, trying to figure out how do we expose this sort of data to webmasters and web developers directly in DevTools to incentivize this sort of structure of your page. So what this tells you is, here's the progress of the page. Like, this is how many pixels were painted, right? So 100 pixels is like we have all of the above default content. And this is time. So 1.2 seconds in, we were able to paint roughly 70% of the pixels. And then the remainder, like maybe images started loading or some other things popped in. But this is kind of your visual progress. And this is the original page at the bottom. So huge difference, right? And if you guys have ever used web page test, the speed index score is actually exactly this. We basically integrate this and we give you a score. The lower score, the better. So something that I'm also happy to discuss if you're interested in this kind of thing. But this is why increasingly we're focusing on rendering speed as opposed to page load time, because page load time can be very misleading. All right, so I think that basically brings us to the end. What does it take to do the 1 second render? Throw away half of your budget on latency. You have to count the round trips. Ideally, you should be able, like in the perfect case, you should be able to render something in 1 round trip. You may not be able to do that, that's okay. But as long as you're aware of these trade-offs. Optimize for above the fold, minimize the use of critical CSS and JavaScript, and defer everything else, right? And watch out for things that you put into your page that may induce more round trips. Things like analytics beacons, social widgets, other API calls, which are non-critical, right? So much of the stuff is actually fairly simple to automate once you know what the problems are. And with that, I think we'll take some questions.
So there weren't any on the moderator.
Okay.
You can remind folks if you want to do that, but if there are questions.
Sure. Yeah. So I don't have the moderator link here.
Put it up front if there are.
Okay. So if anybody has questions online, please feel free, or just ping me afterwards on email. So ilya@google.com. And I don't know if you guys here have any questions. Yeah.
Hi. My question is about the DoubleClick and maps and social widgets. Are there always async versions available? Or is that just something there is?
Yeah, so if you go to, for example, Google Analytics and Google+, they put both.
Okay.
Right? And I've been trying to convince those teams to eliminate the other one, the bad one altogether. And the feedback I always get, and this drives me nuts, is, but people are scared of the other one because it looks like it's a lot more code, right? And so yes, the answer is yes. There may be, specifically for DoubleClick, you may have an instance where maybe for whatever reason your app is specifically designed such that you need the ad to appear in this exact place at this or exact time. At that point, you have to kind of do a more hands-on approach. But the answer is yes. Any JavaScript can be loaded in this way. It's just a question of, is your page compatible with this sort of thing?
Is there any downsides to using mod PageSpeed?
Yeah, so it does a lot of the work for you. Yeah. The trade-offs are, we're going to spend some time on the server, some extra time, which it wasn't doing before, to perform all this additional work, right? So this means, for example, more resources consumed on the server, right? We not only do HTML rewriting, like we can go into the weeds and talk about the latencies and all the rest, but a big optimization that mod PageSpeed does is it optimizes a lot of your images, all of your images, right? We will serve resized versions, properly resized versions, convert formats and all the rest. As you can imagine, image conversion can take some CPU time, right? So we play a lot of tricks, or we do a lot of tricks in the background, things like we'll do the optimization in the background, so the first user may see the unoptimized image, but we'll swap in the optimized image for the second visitor, such that we don't block the first one. But there's basically server resources is the primary constraint. But for most sites, they turn on the fast button, right? So for example, GoDaddy and a lot of other hosts are now deploying mod PageSpeed. They just have like enable mod PageSpeed, and the site just goes faster because we apply this stuff.
Okay, so if you're trying to convince a larger company, like middle to larger company, to use it,
yep.
Is there any way they can judge the downsides? So of course they can see the upside. Is there any way that they have?
Yeah, so oftentimes we, in the larger deployments, we work hands-on with them. So I worked with a lot of larger companies. We have an active Google group and all the rest where people can ask questions about, like, we have a cluster of servers. What are the best way to deploy it? And that's a whole separate conversation because We have layers of caching, configuration, like we can spend 3 hours on that here, yeah.
Okay. And then, has slow start always been around? We never really, okay.
Yep, ever since
1980, that incident you talked about. Okay. And then I have oh gosh. Does anyone else want to ask a question? Okay, you can. All right. So, my other question about the above the fold. So, is that at all a benefit to do? Is it just for mobile primarily, or is there like, oh, that's?
Yeah. So everything that we've talked about here applies directly to desktop. On desktop, so the reason why this is more important mobile today is based on what we're seeing at Google, more and more traffic is migrating towards mobile. Latency. So we know that even on a desktop web, latency is our problem today. This is the reason why we have, at Google started initiatives like Speedy, now it's HTTP2 and other things. Latency is the problem, it's not bandwidth. So if you want to watch a high definition stream from YouTube, you're bandwidth limited. If you're trying to load the YouTube page, you're latency limited. With the migration of the traffic from desktop to mobile, latency is only getting higher, not lower. So this is becoming a larger problem, right? But if you optimize for this above the fold, you'll also optimize the desktop. So all these things apply to desktop as well. It's just more relevant, even more relevant for mobile.
Okay. Thanks, yeah.
Yep.
Okay, I'm done.
Quick question. So any plans to port some of this mod PageSpeed stuff to Jetty? Or is there a way we can even roll on like through some?
Yeah, so the cool thing about mod PageSpeed is basically it runs the server plugin in Apache, right? So Apache can work as a reverse proxy. So what serves the content to Apache is completely, like we're completely agnostic. That could be a Jetty server, that could be a PHP script, that could be a Ruby file, what have you, right? Same thing for Nginx.
Okay, so we could basically front our Jetty with,
Exactly. It's an optimization, think of it as an optimization proxy in between that does this rewriting. Yep.
So if I have a web app that has to constantly push out data to the clients, but I want to obviously optimize it via prefetching, basically so that I'm completely using the full bandwidth of the pipe. That's obviously fine on desktop, but on mobile, most users don't have like an unlimited data plan. So how much prefetching would be polite, basically?
So that's a great question. This is something that we're working through right now in a lot of Google projects as well. And the answer there is, it depends, right? So certainly the connection type matters. So for example, if you're in a 4G connection, actually even in terms of energy efficiency, it makes more sense to prefetch more data on 4G than it does on 3G. Should we expose on the web platform today, we don't actually have like, is this a metered connection or not? Because if you're on Wi-Fi or you're on unmetered connection, we can prefetch as much as possible. But it turns out that probably the most important answer is it depends on your application, right? In the sense that, so for example, let's say I'm building a news app, right? Does it make sense for me to prefetch all of the stories? Maybe, maybe not, right? Maybe if you track my user behavior and you figure out that I'm a sports fan, right, and I've already opted into like I always read the sports section, prefetch the full sports section for me, right? But don't do the politics section or like prefetch the headlines. So there's a trade-off here. And increasingly what we're finding is we need to refine these models based on actual user behavior.
Okay.
So I don't know if that answers your question directly, but
Not really, because we're making BI tools for us.
Sorry.
So yeah, in our case, like that's actually a very good suggestion for anything that has to do with consumer user behavior. But
right.
when you make something like an enterprise tool, then it's much harder to profile.
Right. So I would say, as a base, the thing that
prefetching.
makes sense to prefetch is obviously the critical resources that may block the rendering of the next page or other things, right? So like just figure out what those are, prefetch those, right? That's a base start. And then from there, you can start iterating on like, well, for this specific user, for this specific use case, does it make sense to go beyond that? So for example, We do have prefetch tags in the browser supported today, right? And even on Chrome, we have pre-render. If I'm going through a checkout flow, you know exactly the page I'm going next, right? So you can pre-render the entire page such that when the user clicks next, you don't even have to do a network call. We just literally swap in the background tab, and the user is just right there, right? Which is exact behavior that you want. But that same behavior may not make sense on a general product preview page because the probability of the user going to like the thing you think they're going to go is fairly low. So once again, it depends on your app, right? If you have these predictable chains, you can do a very good job with prefetching. Could you talk about best practices for detecting tap and scroll events in mobile web views? So I'm not sure I have a good answer for that one specifically. I know that in Chrome, we are making, I'm not sure if it's live yet, but we're making a change. So one of the problems with detecting these things is a tap could be a pinch zoom, right, because you're about to initiate something else, or it was an actual click. So for a while, I guess most browsers had this 300 millisecond delay where we register the click, and then we wait to figure out, like, is there more? Are you going to do something more, or was that actually a click? So there's a bunch of libraries that are being used, like FastClick and others, that override that behavior and basically capture that first interaction and pipe that through as an actual click. That is going to be the default behavior in Chrome. That applies to web views as well. So you can use the same FastClick libraries to detect these things and overwrite that behavior. So that's as much as I know about that specific event. And then the second question is, if we use the async JavaScript scripts, how do we know they will execute after the first paint render? Or are there situations they will run before the paint? Right, so what you want to do is make sure that we render something useful and then load it after. So the question is, how do you load it after? The simplest one is to say you register a function that is the onload event on your page. And then as part of that onload event, you do other things. And in fact, if I go back, I don't know if they'll be able to see this. But that is the exact pattern that I used in the example. So in the onload event, I load other files. And oh, here we go. Yeah. So we have this function run after onload, and in my body onload function, I could register that and say only do that afterwards. There are some other tricks that you could do this, but this is a pretty well-known behavior. Just basically run it after onload of the page.
Do you have any specific commentary on frameworks like, well, specifically Angular? I know you kind of mentioned that in passing. Assuming it's not like a separate talk into a separate.
Yeah, so the caveat, once we get into that space of using frameworks like Ember and Angular and all the rest, the gotcha there is you are in fact rendering the contents of the page through JavaScript, right? You're usually constructing your divs and spans through JavaScript. So that creates a little bit more complexity, right? Before I could say like punt all the JavaScript and let HTML define the content of the page. Some of the tricks that are being used today is like, let's look at Twitter and Google+, right? So Twitter, if you guys recall, for a while, had the experience of you load the page, you have the header, and it's just blank for like 3 seconds. And then it pops in. So the reason that was the case was because they would render everything in JavaScript, right? And then they swapped that behavior out, and they said, well, on the first page render, we're going to pre-render that JavaScript template on the server, serve it to you such that the browser could lay it out quickly, and then we'll still kind of capture all those elements on the page and use our JavaScript framework to do the interactivity. Google Plus uses the same trick. We do server-side rendering for the first one. Exactly. So this can be a little bit tricky, but it's certainly doable. I think we need more work in the space, like Angular and other guys. It's something that certainly we've been talking to them about for like, how do we make this simple and easy. Using a templating library that is agnostic, that you could render in JavaScript and on the server. Like, you definitely don't want to maintain 2 versions of the same thing. That's just a disaster waiting to happen. Believe me, been there, done that. So that's one. Another one could be to say, well, if you're not willing to do that, can you inline the critical stuff? For example, the Angular core or other things. How fast can you ship that to the client such that they're not blocked on that? Like, we're making V8 and other JavaScript engines faster and faster by the day. Maybe that's acceptable. It's not going to be as fast as a flat HTML file, but don't block your Angular downloads by other things. Yep.
So, kind of along the lines about the inline JS, if within the company they're like, we're doing this way because it's the easiest way to maintain for a large corporation that we don't have inline JS.
Right.
Is there best practices as to what some of the pitfalls might be about the implementation when they move to this, to like a responsive design or to putting stuff inline, and how to maintain that long term?
Ooh, that's a big question. So there's a lot of pitfalls with responsive design. I think as a community, we're still working through all of the gotchas with that. There's certainly still big unsolved chunks of the problem,
Yeah.
like high DPI images is one that gets brought up very often. I think we're finally making progress on that. Hopefully soon we'll have a solution for it, but that's an instance of a problem. In practice, it turns out that today, out of the sites that we see on the web that are built using responsive design, if you compare them side by side, like mobile and desktop, they're basically the same size. So what it means is we're serving all the same markup. It's just that in the markup, we have some logic to say, if it's this, then render that, which is suboptimal, right? Because ideally, on a mobile connection, you should be serving less. But in practice, it simplifies the implementation. It means there's one code base, and there's just a lot to be said for that, right? So these trade-offs, which we're still working through in the community. In the context of an enterprise, that stuff is tough. Like my answer would be, to some degree, you could just put an optimizing proxy. So any big vendor or CDN will have an optimization product, an Akamai, NF5, or something else, which will do similar things like PageSpeed. Basically, they'll take whatever markup you produce, and they'll try to make it better. And by better, optimizing resources and all this other stuff. If you already have a CDN or you're already working with one of these vendors, it's probably worth checking out because you already have that infrastructure deployed. It's very simple. I know that when I talk to large companies and I tell them about mod PageSpeed, they're like, yeah, this is great. I'd love to deploy it. But my sysadmin is running this 10-year-old server, and I just can't upgrade it. So it can be a tough thing. So using these proxy optimization services could help.
I remember reading a few years ago about Google cheating with the initial window size for TCP slow start. But I mean, yeah, recently it got increased to 10. So would you still recommend kind of pushing it a little higher?
Yeah. So our cheating was exactly 10. The change that was made so up until recently, the initial window size was 4 network segments, which is about 4 kilobytes of data, 3 or 4 kilobytes of data. The cheating part was actually the YouTube team and the TCP team at Google modifying the Linux kernel to run tests to increase that initial window size to 10 and show that we can do that. So the problem with that was, perceived problem was that, hey, if we increase it too much, then we will saturate all the pipes in the internet, we'll collapse the internet, and Google will destroy the internet. Right, so we need to prove that is, we can increase this window. Our capacities everywhere at the edges have grown enough. We have sufficient capacity at the core and all the rest. The actual change in the Linux kernel was contributed by the Google kernel team, and the standard is also updated by the Google team. So the newest Linux kernels start with 10. That's what you should. If you are not running, let's see, 2639. Or later, you should upgrade to that. Ideally, you should upgrade to Linux 3.2 or higher because we already have put in a lot of other TCP optimizations. But that should be your takeaway. Upgrade your Linux kernel, and you're doing the right thing.
Okay. So anything on top of 10 is not worth it?
It depends on. We're actually continuing to experiment. Like, what if we take it to 32? And so far, our results are showing that it's not giving us as much benefit as we thought it would. Right? There's a trade-off.
Were those benchmarks conducted with Speedy or with normal HTTP?
Within context of Speedy, yes.
Really?
Yeah.
Okay.
Yeah.
Okay.
So there's, if you're really interested in this is actually an ongoing discussion in the HTTP2 standardization process right now, where one of the experiments that we wanted to try with Speedy was to actually have custom per client CWINs. Like if you connected to Google and you had previously talked to us and we know that your capacity is high, maybe the server or the client could remember that. Yeah. And next time when we start a connection, we could use that to bootstrap quicker, if you will. So far, it's mixed results. And there's a lot of skepticism in the larger community as to whether that makes sense or not. But that's certainly something that we can talk about later if you want.
Any other questions? Yep. Okay, go ahead.
So like a lot of startups, we host all of our content on Amazon and AWS.
Yep.
Are there other gotchas in terms of performance that you've typically seen for sites hosted in that environment?
In terms of static assets, no. CloudFront is good CDN. They have wide distribution and all the rest. Make sure you are using CloudFront. Don't use S3. If you're using S3, so S3 and CloudFront, make sure that you're compressing the content and serving the right file types. That's for static content. You know, I've run a lot of services, large services in Amazon before, which are dynamic content. There you get into like latency issues in terms of you're running on virtualized hardware and how do you deliver low latency response times. That's a much trickier problem.